array. So we will see first why we have to study antenna array. Usually gain of single element is low in antennas, and so an array is used for increasing gain for long distance communications. And if lambda by 2 dipole is taken as reference, its gain is considered to be around 0 dB. But lambda by 2 dipole is actually having the directivity of 2 dB. Then if two element array is used, it increases its gain by 3 dB, double the gain by 2 times. And if 4 element array we have used, then it increase gain by 6 dB, double gain 4 times. If 8 element array could be used, it increases gain by 9 dB, double gain 8 times. So a progressive increase will be there whenever we use an array of antennas, and it can also be used in beam steering by changing the progressive phase. And we will be having nulling interference directions also. So this has been given in pictorial format. Whenever we use one lambda by 2 dipole, its half power beamwidth will be taken as 78 degree, and its gain should be probably 0 dB. When we use two dipoles like this, 2 lambda by 2 dipoles, its half power beamwidth should be 32 degree, and it will be having a progressive output in both the directions. That is 3 dB gain has been observed. If we use 4 element dipoles like this, that is if we use the number of antenna elements, increase the number of antenna elements, it gives more increase in gain with 15 degree high power beamwidth and a gain of 6 dB. And in a similar case, if we use 8 lambda by 2 dipoles, a further increase in gain will be there in narrow manner. So we will be having a half power beamwidth of 7 degree with 9 dB gain. So antenna arrays are very useful to have beam steering, that is to attain directivity as well as to attain high gain. And if you see these arrays, and if we use n number of elements with equal spacing, it will be named as n element linear array with uniform amplitude and spacing. So identical elements, identical magnitude, progressive phase will be there. It's having also uniform spacing. So the total electric field intensity present over here is given as E1 plus E2 plus E3 up to En based on the number of elements. So here we are having 4 elements, discrete elements at a distance of R1, radial distance of R1, R2, R3, and a linear distance of D. And the phase has been given as I. The first one is taken as reference, and so I. Second one is I into e to the power j beta. Third one I into e to the power j2 beta. And the fourth element is having I into e to the power j3 beta, and it goes on like that. So if we apply this exponential function, E total has been written as the amplitude, the constant amplitude A into I1 into e to the power jk r1 plus I2 into e to the power jk r2 plus I3 into e to the power jk r3 up to In. This A has been given with the amplitude. So it's having imaginary values, and so it has been given as j eta kl by 4 pi r into sine theta for infinitesimal dipole. So in my previous videos I have told you infinitesimal means negligibly small, very minute. So it's not having any discrete values. And here the current flowing is also relative. So because here the current in first element and second element is having phase change only. So this has been given as I2 is equal to I1 into e to the power j beta. And the radial distance between the elements has been given as R2 is equal to R1 minus d cos theta. So we can write E total is equal to A into I1 into e to the power j k r1 into 1 plus, so only phase change is there, and so we are taking every term as a constant term, and we are introducing the phase change terms in the for the next elements. So 1 plus e to the power j beta into e to the power j k d cos theta plus e to the power j2 beta into e to the power j2k d cos theta, etc. So the array factor has been given as 1 plus the summating phase change has been considered with the array factors. So that is how the arrays has been arranged. The elemental arrays antenna elements has been arranged. That is what array factor is. So array factor is equal to 1 plus e to the power j k d cos theta plus beta plus e to the power j 2 into k d cos theta plus beta plus e to the power j 3 into k d cos theta plus beta, etc. So it has been written as a array factor is equal to 1 plus e to the power j psi, where psi is equal to k d cos theta plus beta plus e to the power j 2 psi plus e to the power j 3 psi up to n minus 1 psi. So this is what array factor is. So the array factor has been given as 1 plus e to the power j psi plus e to the power j 2 psi plus up to e to the power j n minus 1 psi. If we have taken array factor in e to the power j psi, it should be written as e to the power j psi plus e to the power j 2 psi, 3 psi, like that up to e to the power j n psi. So subtracting these two, that is equation numbers 1 and 2, array factor in e to the power j psi minus 1 is equal to e to the power j n psi minus 1. So array factor can be written as e to the power j n psi minus 1 divided by e to the power j psi minus 1. That is n number of elements divided by the individual element. So it has been written as e to the power j into n minus 1 by 2 into psi, because whenever we use lambda by 2 dipoles, it has been replaced with n minus 1 by 2. So e to the power j n minus 1 by 2 into psi into e to the power j n by 2 into psi minus e to the power minus j n by 2 into psi divided by e to the power j 1 by 2 psi minus e to the power minus j 1 by 2 into psi. This will again be written as e to the power j n minus 1 by 2 into psi into sine n by 2 into psi divided by sine 1 by 2 into psi. The maximum is occurred when a factor is equal to 0, which occurred at psi is equal to plus or minus m pi. That is, to get maximum differential number and d number with respect to psi, that is when psi is equal to 0, maximum array factor has been achieved. So the array factor for nth element has been given as 1 by n into sine n by 2 psi divided by sine 1 by 2 into psi. From this we can observe main lobe is in the direction, so that psi is equal to kd cos theta plus beta is equal to 0. The main lobe narrows as n increases. So this is the derivation for array factor as well as the explanation for array factor. So for an integer element to the total number of elements, we are finding how the pattern has been realized. Thank you.